Hey students, today we are going to start talking about the metric system, part of our measurement in science. So we know that this is a quantitative observation, so measurements in numbers. You should be looking at this metric system overview. I believe I named it number 1, something to that effect. So basically, all scientists in pretty much the entire world, except the United States and some other smaller countries, use what we call the metric or the international system of measurement. Some of you have heard of this before, used it before. It's a very easy system to use because it's based on the multiples of 10. Our system, the Old English system of inches and miles and gallons and feet, is very challenging to understand because there's not one specific unit we go by. Sure, we could think about 12s, but that's not consistent in all of our units of measurement. So there's 4 basic units in the metric system, and you've probably heard of them before. The meter, which we utilize to measure the distance of something from point A to point B. We have the liter, which measures the volume. So I have 2 pieces of glassware right here, the beaker and the graduated cylinder, that help us measure the volume. These actually will measure in milliliters because it's a very small measurement of liquid. And then we have, of course, the gram, which helps us measure mass. This is the scale, and we also have a triple beam balance that we can utilize to measure the mass of something. And then, of course, temperature with a thermometer. We don't use Fahrenheit, we use Celsius. So these are kind of the 4 basics of the metric system that kind of help us think about if we're measuring the distance of something, the volume, the mass of something, or the temperature. Okay? So looking at your sheet in front of you or on your screen, you will notice that we have prefixes. So kilo all the way down to milli, and our base in between. Okay? Kilo is the largest unit we're going to work with this year. Does the system go higher than the kilo? Absolutely. But for our purposes right now, we're going to stick with the kilo. It is the largest unit. We abbreviate it with the letter K. I could have a kilogram, a kiloliter, and a kilometer, depending on if I am measuring the mass of something, the volume, or the distance. And this is 1,000. Then I have the hecto. Stands for a letter H. It's 100 times the quantity. And I could have a hectogram if I'm measuring the mass. I could have a hectoliter if I'm measuring volume. And I could have the hectometer if I'm measuring distance. Next is the deca. Now this one's a little bit tricky because I've seen it 2 different ways. Why scientists can't figure out one way to abbreviate it is beyond me. But I usually see it DA, though I have seen it abbreviated DK. This stands for 10, a quantity of 10. So I could have a DAM, I'm not going to pronounce that because that probably is not the most appropriate thing to do. But I could have this if I'm measuring the distance of something. I could have DAL if I'm measuring the volume. And I could have DAG, DAG, if I'm measuring the mass of something. Then we have our base units. We have the meter, we have the liter, and we have the gram. You'll notice that these can all stand alone, like you've seen 1 meter stick, but if we're measuring something of a longer distance, I can hook kilo to it, and I can consider it kilometer. Some of you probably, if you've been to different countries, have seen it doesn't say on the exit signs like 2 miles till exit 20. It will say something in kilometers because they're using the metric system. This is a base of 1. So all of these can stand for one, such as 1 meter stick that some of you probably have seen. You probably have seen a 1 liter bottle, like pop or some sort of liquid. And then 1 gram. 1 gram is about the mass of a, what is it, Rory?
Paper clip.
A paper clip. Okay. Now we get to our smaller units. I need to erase this a little bit because I'm going to run out of room. All right, our smaller units. Deci, which stands with the letter D, not to be confused with DA or DK, is a tenth. So I could have a decimeter, a deciliter, or a decigram. I always remember the difference because if it has 2 letters as our abbreviation, it's bigger. If it only has 1 D, it's smaller. Then, oh, this is the one you're all familiar with, the centi, abbreviated with the letter C, and this is a hundredth. So we have centimeters, centigrams, and centiliters. And then our smallest unit, yes, it does go smaller than milli, but for our purposes, we're going to just stick with the little milli. We abbreviate milli with the letter M, and this is 1,000th. Millimeters, which you probably have seen on the ruler with centimeters. Milligrams. Hey, some of you probably take medication in the form of a pill. That's in milligrams. Those capsules are measured out in the amount of quantity of medicine that you take in that little capsule or pill. And then milliliters. For those of you that take liquid medication, there's that little cup that somebody would measure with milliliters. It's no longer, hey, take 2 teaspoons or tablespoons. We really like to use that. So here are our metric systems. So these are prefixes, what I'm highlighting here. And a prefix can be hooked to a base. So I can have a kilometer if I'm measuring a long distance. If I'm measuring something really short, I'm probably going to have a millimeter. So we use these prefixes to hook to the base, or the base can stand alone. Here's what I'd like you to do right now on your doc. So you'll notice on your doc, I believe it's page number 3, that you are going to read the article about the metric system compared to the customary system, then answer the questions that follow using complete sentences. So this kind of gives you an overview of the metric system and the differences between this and the Old English system. And then on page number 4 of your doc, there are 3 questions that I'd like you to respond to for today.